So we're going to graph some parabolas. All right, we're going to do a few things here on this one. We're going to identify the vertex. We're going to identify the axis of symmetry, which we'll talk about in 1 second. We're going to figure out whether the vertex is a min or a maximum. We're going to find the x-intercept. Eventually, we'll go to the y-intercepts. We're going to sketch the graph. We're going to state what the domain and range is, and then we're going to find the average rate of change on the interval h, comma h plus 4, and I'll show you what that mean by that in a second. And these actually should be brackets, not parentheses. All right. So identify the vertex. So we have this already in vertex form. So let's do this piece by piece. What is the vertex? Yep.
3, 1.
Yeah, perfect. So my vertex is 3, 1, and I'm getting that from here, where if f of x equals a times b x minus h squared plus k, and the vertex is here at hk. Perfect. All right. It says axis of symmetry. We'll hit up in a second. Min and max. We'll do that in a second. The x-intercepts. Sketch the graph, domain and range, and the average rate of change. So let's go to graphing this so we can figure out the rest of this piece, right? So, and again, I'm not going to do this in any particular order, but here's the graph. So I got my vertex is 3, 1. I'm going to plot that 1, 2, 3, 1. There's the vertex. Let's figure out some values to the left and to the right of this. So let's figure out what f of 2 is. So one x value below the vertex. And let's figure out what f of 4 is. One value after the vertex. And I want to do this on the calculator with you guys too. So actually, let's go to the calculator in this part, right? So let's put this on the calculator so we can figure all these numbers out nice and easy. Right now, the numbers are pretty easy to figure out, but we'll verify them on the calculator as well. So we got x minus 3 squared plus 1. Let's put that in our calculator. So if we have a calculator on, so I'm going to go to y equals, and in parentheses, I'm going to have x minus 3, close parentheses. The square button is here, 3 characters down from the green, squared plus 1. All right. So I want to get some x values and some y values from here. So once I have my equation in y1, does anybody remember how to get that table to figure out what the x values and y values are? Yep. Yeah, nice. So if we hit second graph, we'll get to a table. So depending on what you have, I'm going to delete these. I'm just going to hit delete on top of these numbers just to give myself a clean screen. So again, you can either have it in this form or you can have it in the other form. Don't change this if you already have it here. So if you have your table set in this form, auto, don't do this. So when you go to second graph or second table, you might see this, a bunch of numbers here. That's one table setting, or the other table setting, which I made you guys change already. I like this table setting particularly. So I always put that to ask, so that way we could ask the calculator whatever x values we want. So we said my vertex was 3, 1, so I'm going to use a y value of 2, and what do I get? When x is 2, y is 2. And what happens when x is 4, when I go 1 to the right of it? Yep. Y is 2, right? So it should be symmetric. So if I use one x value to the left, one x value to the right, I should get the same y value. Just confirming it. And I'm going to get myself another y value. I'm going to do 1, and I'm going to do 5. So when x is 2 or 4, y is 2. When x is 1 or 5, y is 5. So I'm going to bring that back here. F of 1, f of 5. So we said 2, 2, 5, 5, and you should get your x values that way. That's nice and easy. Or you could plug into the equation here and do it mentally. I like the graph. I like the calculator piece though. All right. So now we got 2, 2. So 1, 2. 4, 2. We got 1, 5. And 5, 5. All right. And again, this is a parabola, so it's going to make a U-shaped curve. And now we have our U-shape. Again, the absolute value was the V value, was a V. We have the square here now, so it gives it your U shape. All right, so we got our vertex 3, 1, 2 values to the right, 2 values to the left. Go to the calculator piece of it, get your values that way. Let's bang out the next one. So we have the vertex. I want you to tell me whether the vertex is a max or a min. All right, looking at the graph, right? Is the vertex the bottom of the graph, or is it the top of the graph, right? So it's a parabola. It's going to be one or the other. Is it the bottom? Is it the absolute minimum value? Or is it your absolute maximum value? Which one is it?
Mid.
Yeah. So this is going to be the minimum here, right? So the vertex is a min. So I want you to label that as well. The axis of symmetry, yep, question?
So if there's like a reflection over the x-axis, then would it be a x?
Yes, so perfect. So if there's a reflection over the x-axis and it's coming down, the graph is going down, that'll be a maximum. Beautiful. Yep. So we have our third part here, which is the axis of symmetry. All right. I'm going to abbreviate axis of symmetry as AOS. You'll see that abbreviation often. So the axis of symmetry is where the graph splits perfectly. All right. So if I graph this, so if I just draw a line here, this is where the graph is symmetric. Okay. So the axis of symmetry is a vertical line. What is the equation of a vertical line? Yeah, x equals, and this is nice and easy. It's always going to be x equals, and just take the x value of the vertex. Right. The x value of the vertex will always be the axis of symmetry. Where do I split the graph? Right at the vertex. Fold it over in half, the graph, the right side will land right on top of the left side. With me? Next piece here is the x-intercepts. Where does the graph cross the x-axis? Where does this graph cross the x-axis? It doesn't graph, right? So does this graph cross? Is there any point on this? Is there any point on the x-axis that the graph crosses? Nope. So on this particular equation, we say x-intercepts. We could just say none. In algebra 2, we'll get to imaginary roots, and you'll get there soon enough. Not yet. Yep. X-intercepts. Yeah, I want x. Right? I want x-intercepts on that one. And here's the last piece, which we haven't done yet either, is the average rate of change on the interval h comma h plus 4. All right, so what's the h value right now? What's my h? 3, right? So the h is just my vertex, right? The x value of the vertex, so 3. And then add 4 to it. So if you add 3 plus 4, we get 7. So I want the average rate of change on the interval 3 to 7. I want the average rate of change on the interval 3 to 7. What is the average rate of change mean? In other words, what am I looking for? Average rate of change. What does that mean?
Like if it's increasing, how fast it increases.
Okay, and what's another word for that? Slope, right? The average rate of change is just a slope. We've found slopes plenty of times. So to find slope, I need 2 values. So when x is, so what is f of 3? F of 3 is equal to, we got that already? What's f of 3? 1. Beautiful. And what is f of 7? Again, you can plug in, or I like this piece here. Just plug in 7 into your calculator, hit enter, and get the y value, right? So when x is 7, y is 17. I want you guys to start using that more often, all right? I know you can do the mental part of math of it, but start using the table and the graphing calculator. So we got 7, 17. Beautiful. Now we have my x1, y1. We have x2, y2. Let's find our slope here. M equals 17 minus 1 over 7 minus 3. 17 minus 1 is 16. 16 over 4. And our average rate of change on the interval 3, 7 is equal to 4. Now what do I mean by that? The average rate of change. All right. So again, if I'm looking at a value here at my vertex, right, I have a dot here on my vertex, and when x is 7, 17 is around here somewhere. Let's imagine that, around there. The average rate of change, if I were to draw a line from the vertex to that slope, right, so my line is curved. Is the slope consistent? Is the slope going to be the same on a curved line? No. So I can find the slope at any point on this line, but not until I get to calculus 1. So for now, we're going to say, okay, well, since I don't know what the slope is on every part of the line, I'm going to say, what's the average slope? And I'm going to say, okay, what's the average slope on the interval? 0 to 4. And I'm always using the same interval here, where it's just take the x value of your vertex, add 4 to it, and find the interval on that particular piece. On the quiz or test, I will probably I'll give you those numbers, definite numbers there. We'll just go from your vertex, 4 more units, and find your average rate of change on that line. Questions so far? Yep. Yep, domain and range. Yep.
How do you get the 3, 7?
The 3, 7. So once I got my vertex is 3, correct? Just take your vertex 3 and add 4 to it, and you get the interval of the rate of change. And you always do that for all of them. All right, let's find my domain and range. Let's give this on interval notation. What is the domain of this function? What is the domain of this function? Again, domain, start from the far left of the graph on the x values. How far to the left will the graph go? How far to the right will the graph go? What is the domain interval notation? Beautiful. So it goes as far left as negative infinity in parentheses, all the way to infinity in parentheses. Yep. Range, all yours. Beautiful. Bracket, I'm including the number 1 in there, right? The graph goes as low as 1. How high does the graph go? To infinity and beyond, right? And then we have our range here. So let's double check. We got a vertex, we got our axis of symmetry. We said the vertex is a min. We have our x-intercepts. We said there was none. It doesn't cross the x-axis. We got a sketch of the graph. We got the domain and range. And we found the average rate of change on the interval h plus 4. Here, we're going to do all the same pieces. Let's get my vertex out of the way. What's my vertex? Beautiful. So my vertex is -2, 3. Again, my h, my k. It's not a positive 2, right? Because the form is x minus something, so h has to be -2. Vertex and the vertical shift is up 3. Beautiful. We got the vertex. We could nice and easily now get the axis of symmetry without the graph. What is my axis of symmetry here? Once I know my vertex, I know my axis of symmetry. Yep.
-2.
So it's an axis of symmetry is an equation, so it's not just -2, it is x equals -2. Beautiful. So x equals -2 is the axis of symmetry. If you want to label that on your graph, I'll take that right now. Right? So the graph is going to split on that line there. All right, we're going to figure out if it's a min or max in a second. We're going to figure out x-intercepts. We're going to sketch the graph and domain and range. Let's do the sketch now. All right, so we have our vertex is at -2. Let's get some values to the left of -2. Let's get some values to the right of -2. All right, so I'm going to find what is f of -4. I'm going to find what is f of -1. Those are 2 values to the left. Now let's go 2 values to the right. F of, I'm lying there. This should be f of -3. And then I'm going to go f of -1 and f of 0. All right, let's put this into my calculator. I'm going to go back to y equals. Let's store that in there. So I got negative. The negative is underneath the 3. Remember, absolute parentheses, x plus 2, close it, squared, plus 3. Get that into y1. All right, so for me to find my values, again, I could just plug them in, but I'm going to use the calculator just in case I have fractions and it takes too much time and all that decimals. I want to be able to find all my values nice and easy using my tools and my calculator, all right? So do we have our equation in the y1? So far, so good. How do I get to the other coordinates? How do I find my other coordinates? Yep. Beautiful. Second graph, which is my table. And I'm going to choose some values here. And again, if you want to get rid of these values, just hit delete on top of the number, and you can delete them. So we said my vertex was -2, so let's go -1. -1. I get 2. What happens if I choose -3? What happens if I go 1 unit to the right, 1 unit to the left of the vertex? Yep. Yeah, it's going to be symmetrical, so that means I will have the same y value, okay? And I'm going to do -1, and I'm going to do 0, and get -1. So, again, if I want to verify, I'm going to do -3. I should get 2. I'm going to do -4. And I should get -1 as well, right? 1 unit to the left of the vertex should give me the same y value as 1 unit to the right of the vertex because of the axis of symmetry. All right, so let's take those coordinates. 2 and -1. So we said f of -1 was what? What's f of -1?
2.
F of -3 is going to be 2. What's f of 0? -1. And f of -4 is -1. All right, let's plot those bad boys on the calculator. So we got -2, 3. -4, -1. Which means I have -3, 2. And again, this is going to be symmetric. Just joking. -4, -1. And we got here. All right, and in my graph, again, do your best to make it look like a U, not a V, so we could distinguish between a parabola and a absolute value function. All right, beautiful. Is the vertex a min or a max at this point? Is the vertex a min or max? Beautiful. It's the highest point, therefore it's a max. All right, so we got. Let's see where we are so far. So vertex check, axis of symmetry, min or max, x-intercepts we'll do in a second. We sketched the graph. Can we figure out the domain and range now? Let's bang out the domain and range. What's my domain? What's my range? Yep.
The domain is -.
Beautiful. How far does the graph go to the left? All the way to -infinity. Parentheses. How far to the right? Infinity. Parentheses. What's my range? Beautiful. So how low does the graph go? It goes as low as -infinity. What's the highest point on this graph? The y value of 3, and it includes the y value, so we take the bracket. Awesome. We got domain and range. While we're at it, let's do our x-intercepts. All right, let's use our calculator to find our x-intercepts. Eventually, we will start graphing these, and we will do this part manually. But I want you guys to learn on the calculator first. How do we find our x-intercepts? What's another word for x-intercepts? When y equals 0, so if I'm using my graph, all right, so I have y equals. If I look at the graph part of this, does that graph cross the x-axis? How many times? Twice, so I should have how many zeros? 2. How many x-intercepts? 2. What's the difference between zeros and x-intercepts? Same thing. Beautiful. All right, so how do I find my zeros? Yep.
Second, trace, which means calculate.
Excellent. So second, calculate. I'm going to calculate something. I'm going to calculate my zeros. Beautiful. So I could either go down to number 2 or I could just hit the number 2. All right. Left bound. So I'm going to bring my sprite. I'm going to go left to right. So left bound. All right. So pay attention to this, right? So left of the x-intercept, hit enter. Look at that first line that came up. You see the first line in the arrow? So I'm bounding this, right? So I'm saying, okay, I'm going to look at the graph from that part all the way to, and then when I go right bound, I'm going to go above the x-intercept. And then I created these 2 arrows pointing towards each other. So in that region, where's the y value 0? The y value is 0 at -3.73. We'll just round to the nearest hundredths. So -3.73, comma 0 is one intercept. Aren't you happy you have a calculator for this part? And let's get the the other x-intercept. I'm going to do it again. Second, calculate. 2, left bound. Ladies and gentlemen, the left bound on this side. Again, you're following the graph left to right. So this, now I'm above the x-intercept. Right, I'm above the x-intercept on this side. So I hit enter. It's going to tell me look at the graph from left to right. So in this region here, bring the spider below the x-intercept. Hit enter again. So again, it's going to create those 2 lines, those boundary lines there. It's going to point towards each other. So in this range here, so in this interval here, where is the y value 0 is what it's asking. So this one should be pointing right. This one should be pointing left. So in this boundary, where's the y value equal to 0? That's what you're telling the calculator or asking the calculator to find for you. Right bound, left bound, guess, it doesn't matter. Hit enter, and we got -0.2, we'll do -0.27. So -0.27, comma 0, and those are my x-intercepts. Questions so far? Last one, and I'll stop. And let's do our interval on what's the x? Our x value is -2. And let's add 4 to that, and we have a y value, another x value of 2. So what is the average rate of change on the interval -2, 2. First question, what is f of -2? This one we got. What is f of -2? 3. And let's find what is f of 2. What is f of 2? Use your calculator to find f of 2 if you want, or you could plug in. What is f of 2? What is it? -13. Do I hear a confirmation on -13? Yes? Okay. So we got an x value, y value of -2, 3. So let's find my slope. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. -13 minus 3, -16. 2 minus -2, 4. And the average rate of change on that interval is -4. All right. So I'm saying what does that look like as a visual? So from this point here in red, all the way to when x is 2. So when x is 2, we're down here somewhere. So if I drew a line from one point to the other point, what's the average rate of change? What is the slope of that linear equation? The slope is -4, and that is your average rate of change. The square root function, all right? So we're going to use the same type of formula. If you're looking at the formula here, f of x equals a times the square root of b times the quantity x minus h plus k. What is my vertex? You haven't done this one yet, but look at it. It's the same concept. What's the vertex? What is the vertex? What is the vertex? Come on, 3 people, I want more. What's the vertex? Look at it. Look at the form. Look at this. What's the vertex? Yeah, give it to me. Almost. Why is it +4? The formula says x minus h, x minus 4. Right, the minus sign belongs to the formula, so the vertex is just 4, -5. With me? So my vertex here, let's find a couple of these pieces here. And there's not as much in this one. So vertex 4, 5. It says domain and range. Let's sketch the graph before we find the domain and range. And again, I'll give if you have graph paper, great.
Wait, 4, -5, yeah.
That's what I said. 4, -5. So we got 1, 2, 3, 4. 1, 2, 3, 4, 5. So 4, -5 is here. And then let's pick some values, some other values. So this one I'm going to get a little picky on the values I choose. Right, so when I get picky on these values, so when I take the square root of a number, I'm hoping to take the square root of a number that I can take the square root of. So I can take the square root of 0, I can take the square root of 1, I can take the square root of 4, I can take the square root of 9. Right, so I want to try to get those values in there. So what value can I plug in for x that's going to give me square root of 0? 4. So what is f of 4? F of 4 is 0 minus 4, which is, 4 minus 4, which is 0, square root of 0. 0 minus 5, -5. So when x is 4, y is -5, so we got that one. Let's pick another value, so that was my vertex. Let's get this x value to be 1. So what can I plug in for x so I can get the middle here to be 1? Yeah, so f of 5. So 5 minus 4 is 1, square root of 1 is 1, minus 5 is -4. So when x is 5, y is -4. Let's go one more. I got 0, I got 1, let me get a 4 in here. What can x be here? What's up for x? Yep. 8? Yeah, beautiful. 8. 8 minus 4 is 4. Square root of 4 is 2. 2 minus 5 is -3. So when x is 8, 1, 2, 3, 4, 5, 6, 7, 8. And again, sorry for no graph paper on this one. And then we have our general shape of the graph that looks something like this, and it's going to go on and on and on. All right. So this shape is really a parabola minus half of it, and it's tilted onto its side. So that's the parent function of what the square root of x looks like. So it's like a half a parabola tilted on its side. Yep.
What's the line that comes in the second one?
Here? There's nothing here. It starts here and it goes on to the right. All right, so the parabola starts at a certain point. This is kind of like the vertex and then goes out. Yep. Is there a reason why I chose 8? Yes, because I want to get the square root of 0, square root of 1, square root of 4, square root of 9. So I'm asking myself, what x values can I plug in here to get those square roots? So if I plug in 4, I get 4 minus 4 is 0. If I plug in 5, I get 5 minus 4 is 1. If I plug in 8, 8 minus 4 is 4. And if I do 13, 13 minus 4 is 9, if I want to continue on that way. All right, so I want to try to get myself some perfect square roots. And if I'm here, let's go with, we got my vertex. What is my domain and range? What is the domain and range of this function? How far to the left to how far to the right can it go? Yep.
Bracket negative
4.
4, comma.
Okay, so it's going to go as far as 4, and we'll move on to infinity. And what's my range? How low can this graph go to how high can this graph go? What's my range here? Yep. Bracket negative 5, comma infinity. So the graph will go as low as negative 5. How high will it go? It'll go as high as infinity. Beautiful. And then find the average rate of change on the interval h on the interval. So let's go here. The average rate of change on interval. My vertex is 4, comma, and let's add 4 to it. So 4, comma 8. So we said f of 4 is negative 5. F of 8 is what? Is negative 3. Awesome. And then let's find the slope here. Negative 3 minus negative 5, which is 2. 8 minus 4, which is 4. And the slope here is 1/2. So the average rate of change on the interval 4 to 8 is 1/2. And again, you can use your calculator to find the values. Plug these in. Let's plug this one in on the calculator just so we can figure out the square root. We got y equals. I'm gonna leave this first I'm gonna leave the first equation on there. I'm just gonna go over the equal sign, hit enter to de-highlight it, and then I'm just gonna put the second equation in here. So I have the square root, which is second x squared and I'm going to plug in my function there, which is x minus 4, x minus 4. Make sure you hit the arrow to get out of the square root, minus 5, and then I'm going to graph this one, and I should see the graph there going from that way. All right, and if I want the values again, like you said before, we can hit second table, and we can get whatever y values we want. So we did a y value of 4, enter, 5, enter, 8, enter, 13, enter. These are all the ones that gave me perfect square roots, and you can get all the values that way. Okay. So again, we got the domain and range, check. We got the sketch of the graph, check. And the average rate of change on the interval h comma h plus 4. And we wrote down our vertex.